Okay, so I think the next step is to switch over to Everybody Codes and do the next puzzle there. We have quest 4 to work on. You can see I'm kind of behind the times here. That's okay. This is just practice. Let's go over there. Doc, dev, Everybody Codes, KOA 2024. Bacon. Oh, do I have separate? Yeah, under solutions. That's it. That's the way I'm working it. So let's make a new cargo new day 04. CD day 04, bacon test. Let's just work in test mode here. CD day 04. Oops, solutions day 04. Make their input. All right, let's read this problem. I think we're ready to get going. NVim source main. Yeah. All right, Everybody Codes. Kingdom of Algorithmia, Quest 4, Part 1. The Royal Smith's Puzzle. All right. Now I'm really liking these wood carvings. Or wood block prints. One of the grand tournament's most time-honored traditions is the Master of the Royal Forge Challenge. Knights proceed to the colossal forge where a song of steel echoes from afar. The king's... Oops. Hit the spacebar. The king's smith awaits, silently gesturing towards a section of the courtyard where wooden logs have been meticulously arranged. Massive nails, with heads the size of a human hand, are embedded in the logs. Wow. Those are big nails. Next to each log lies a hammer. Each contender stands by one. The blacksmith explains the rules of the first round. Several nails have been driven into the top of the log, each protruding at a different height. You must drive the nails into the logs so that their heads form a perfectly straight line. Perfectly straight line? I don't know what that means. You begin hammering, but it's hard to tell if the nail has moved even a fraction. It seems that this will be a test of endurance. To pass the time, you note that the length of each nail protrudes. It turns out that they are precisely measured, each expressed in whole units. Okay, so these are quantum nails. Additionally, you notice that each nail head has a small black dot in the center. Examining your hammer closely, you find a similar dot on its head. You take a swing, aiming to align the dots upon impact. The nail drives into the log exactly 1 unit deeper with each strike. Yeah, okay, quantum nails, no problem. We can handle that. It's not about endurance, but precision and accuracy. The blacksmith glances your way and smiles knowingly. You know the length of all the nails, so you can calculate how many strikes, at minimum, it will take to align them all perfectly. Example, based on the following notes, 3, 4, 7, 8. The length of the nails are 3, 4, 7, and 8 units. The shortest nail is 3, and the rest must be leveled to this height. Got it. It takes 1 strike to drive a 4-unit nail 3 units, 4 strikes to bring the 7-unit nail down, blah, 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 until you need 10 strikes of the hammer. What is the minimum number of hammer strikes needed to level all the nails? All right, let's grab our input. 31 bytes, so not too many nails. Downloads, Everybody Codes to the input directory here. We're going to take a look at it. Okay, so we're going to level them all to level 7. We can do that. AOC lib read. Oh, we might have. Oh, right. I have to modify my cargo toml. AOC lib workspace equals true. Save that. Flip over here. And I think I have a read numbers. Yeah. And I can just give it this file. And if I say let nums nails, let's call them nails. Println nails. Oh, I have to tell it what type it is. Is it vec usize? Oh, I don't have a test yet. I guess what we can do is run this as a test. 3478. FN part 1. Nails. Usize. And all we're going to do is return the number of hammer strikes. And just for now, it's 0. Test part 1. And we're going to assert equal 10, part 1. It's going to be given, come on, ampersand, there we go. 3, 4, 7, 8. And that fails. So now all we need to do is find the minimum and then calculate the differences between the minimum and each one of them. All right, so it's O of 2n. Let's see, let min equals nails, iter, min, unwrap. And then we're going to return nails, iter, map, nail, nail minus min, sum. And that test passes. So now this is just, we can hit run over here and it should just give us all the nails right now. But we can call part 1 here, println part 1 equals some value. It was just part 1 of nails. 78. Let's see if 78 is correct. It seems right. I'm on a quacking roll. 598. Really? Okay, less than 600. Not bad. Let's commit that. That's right. The cargo lock changes every time we add a new KOA 2024 Quest 4 Part 1. Every time we add a new puzzle. Okay, so part 2. As soon as the last nail is perfectly aligned with the others, the log begins to rotate with a soft creak, revealing another side bristling with many more nails. Okay, each awaiting its turn to be leveled. Despite the seemingly endless challenge, the rules remain unchanged. Your task is to hammer each nail into the log until their heads are perfectly level, forming a straight, unbroken line across the surface of a log. You take a deep breath, knowing that precision and patience will once again be your greatest allies. All right, so I'm guessing this is just bigger. Yeah, it's about 1,000 bytes. We can take a look at that. Okay, I'm not sure what this is supposed to prove, but we'll just do it again. Part 1 changes to part 2. We still call it part 1. Maybe we change the name of it now. Instead of part 1, we call it parts 1 and 2. And we got a number. That's some quacking genius. All right, 592. So about the same number of people have solved parts 1 and 2. All right, so let's see what part 3 is. Is it a little more difficult? You're getting the hang of it and swiftly complete the task. The log rotates again, revealing another section filled with nails. This time, however, okay, we got something different. The nails have additional white dots. Inspecting your hammer once more, you notice that the other side of the head has a corresponding white dot. Curious, you align the dots and strike. To your surprise, the nail moves up exactly 1 unit. The nails are much longer than before, so it would be wise to level them in the most efficient manner possible. To achieve this, you must first determine the optimal height to which the nails should be driven, or pulled, so that the total number of hammer strikes is minimized. Okay. Example based on this. Oh, that was interesting. I think I saw that before last time too. Yeah, copied. Okay. So test part 3. I'm going to say assert equals, what is this? 8 hammer strikes. Part 3 of this. Oops. I guess it would help if it had commas in between each number. And a comma here. There we go. And we don't have part 3 yet. Oops, that should be a 0. Okay, Should be 8, and we're coming up with 0. So I guess one way we could do it is loop over all the nails. I mean, there aren't, how many are there? Let's get the input here. How big is it? 4.4K. That's not that bad. I'm pausing because I wanted to check in part 2 and I didn't commit part 2. And now we have this. What's the interactive one? Git commit -p. It did the whole thing. No. I thought I could have it do, so each one could be separate. All right. So what we'll do is we'll just undo part 3 here. And then we can redo it, I think. Git diff, git commit -am KOA 2024 quest 4 part 2. And now, yeah, I can't do that again. Okay, so I'll just type it again. Test part 3. It's 8 with part 3 of 2468. Close bracket. Close paren. FN part 3. Nails. usize 0. Okay. Back to part 3. So in order to solve this one, I think what we need to do is just loop over all the nails and then see how many nails it takes to get to that point. We can use the same thing that we did up above in parts 1 and 2. So we could say for nail in nails. All right, this is just going to be a reference to the thing. And now we can use this as our nail, and we can calculate a minimum on this guy. I'm going to do it a little sloppily, and then we can make it functional. Let mut min equals usize max. And then we can just return min here. And we could say min equals min of nails iter map nail other. Let's call it other. Nail abs diff other. Sum. I might have to tell it to sum to usize. Let's consider dereferencing. Yeah, so that solves part 3. Let's see if it solves part 3 for real. Part 3. Run. It's a bigger number. Yeah, I'm cracking brilliant. Look at that. 581. 581 people have solved this, or I'm the 581st person to solve it. It took me 13 minutes and 26 seconds. Okay. Nice. Okay, that wasn't bad. I think we can make this simpler or more functional if we just say nails iter map nail. And then we can do this. And then min that. Will that work? Oops. Unwrap. Yeah, is that the same number? Yeah, look at that. that worked. Is there anything else we want to do there? Because when you're playing around with Rust, your brain kind of jumps to creating traits and creating a trait that implements this inner bit here. So we could just map over that function. Yeah, the only other thing is this. I mean, this is other business here. Can we do that? Well, let's commit this change first. Git sys git commit -am part 3. Let's push that up for now, and then let's just play around with it a little bit, because that's what Rust is all about. Is really this behavior modification stuff. What we can do is we can create a trait called a mindiff trait, maybe, or a abs diff that we can implement for an iterator. How would we do that? I mean, there already is an abs diff. Diff list, we'll call it diff list. And it would take a self and a number to diff against. Or so maybe it should be a diff sum. Let's call it diff sum. And it needs a type T. And we do it this way, and then returns a T. Oops, forgot that part. Right, so we're not using the trait yet. So if we impl diff sum for I wonder if I can, if I create a impl it for a vec, then we can't, can we do it for a slice? Will it automatically do that? Oh no, we actually don't want this. We want, diff sum usize for vec usize. Will this work? And then self is the vec of usize, and we can say self iter map other num dot abs diff other. I might have to put 2 stars there, and then sum. Okay, and then here we can say nails diff sum nail. No method name diff sum on this because it's this. Can I do that without going into lifetime issues? I can. Okay. So now this gets it down to a single line, and then we should be able to also do like a mindiff trait on this, right? Trait mindiff t fn. Oops, I keep doing that. Fn mindiff self. And it returns a usize, right? And then we can impl mindiff And it's just this line here, right? And instead of this, it's self diff sum. And then over here for this, we could just say nails min diff and return that. Yeah. So part 3 is just nails min diff, which means we can just say nails min diff. I guess not. Oh, because it's a VECU size. Okay, we can fix that, right? And it would be nice if I could make it generic over T. Oh, because now diff sum is not implemented for this. Yeah. And now we don't need this anymore. Yeah, look at that. And then for parts 1 and 2, it's just the inner part, right? So it's just diff sum of the minimum. Let min equals nails min unwrap. Nails iter min unwrap. And then we can just say nails diff sum min. Yeah. We can get rid of that, and we do the same thing here. And we get the same answer. And now the tests won't work because we don't have the functions anymore, but we can implement this, right? Vec bang diff sum 3. Oops, I forgot something here. Diff sum ampersand 3 takes a reference, and then this becomes vec bang min diff. Oops, again, I did too many of those things. Yeah, there you go. See how cool Rust is once you implement a million traits? It would be nice. So I have T here, and then I should be able to implement it for any type T that can call abs diff. Oh, maybe not, because I don't think abs diff is traitable. I don't think it's a trait implementation. Oh, there's 2 different places where it can be found. Actual T target pointer width is 64. Okay. Actual T and signed T. Widening impl. Midpoint impl. Yeah, so there must be, so this uint impl macro must implement abs diff. Yeah, right here. So it implements abs diff for an integer type. Trick LLVM into generating the PSADBW instruction when SSE2 is available, and this function is auto-vectorized for U8s. Okay. So I guess that just allows you to do an abs diff across multiple bytes at once. Yeah, it's just doing this. So maybe we do this, right? Let's flip back here. Back to the code. So I think what we can do is just implement our own diff. Trait. I don't know why I'm doing this. This is not Advent of Code or Kingdom of Algorithmia, but I'm just doing it for fun. Let's call it absdiff. Absdiff. T. Self. Oh. Other T. This might not T. This might not work. But we can try it. What we can do is we can implement it here and then try to say impl it for usize. Let's just try. Because I think we're going to need to add a where clause. Right? We're going to need to be able to do a comparison if self is less than other. Then other minus self, else self minus other. And we might not be able to do these things. Right? It's going to tell us that we need to include, okay, partial ord and the sub traits. So yeah, we have to add these as where clauses. Where self, partial ord, T, and T, it's saying T needs to implement the sub. Self output equals T. I'm going to have to pull these guys in. Oh, partial order is already there. Sub is not. And now it's saying, oh, now we have to add a lifetime to it. What if we made it copy types? Because we have copy types. And now it doesn't like this. Consider restricting, can I subtract T from self? Oh, I see, where self gets sub T. And output is T. There. So now we have absdiff. Not for anything, but what we can do is now change this to a T, right? And output is T here. So now it should be implementable for any impl T, diff sum T for rect T. And now we need to have T implement absdiff. T. Ooh, that blew up everywhere. Right, because we didn't implement it for okay. So now we should be able to do this here. T, 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 T. We're getting close. Expected use size, so this needs to be a T. Diff sum cannot be called vec use size due to unsatisfied trait bounds, right? Because now we have to impl absdiff for I thought you could implement. Oh, maybe this needs to all be self. And that way we get rid of this whole T business altogether. And maybe partial or doesn't need that. Okay. So value of type T can't be made by summing an iterator over elements of type T. Oh, so diff sum definitely needs something different, right? You have self T. Yeah. That's right. So whatever this is. So this is saying value type T can't be made by summing this. because this doesn't implement sum. So maybe this needs to implement sum or add. No, it still doesn't work. Ah. Is there something that sum is expecting to be implemented? It says self-sized. Oh yeah, there's a sum trait. Okay, we're getting closer. Now diff sum doesn't work because method cannot be called on vec t due to unsatisfied trait bounds. So that means that this also needs to be summable and diff summable, abs diffable. And min. So a trait ord is not implemented. So this needs an ord as well for t. Expected 0 generic arguments. And now we just have a warning here that we're not using add. The test pass. Oh, look at that. So now we did it for a generic type, right? These are use sizes here, but if I change these to I64s and an I32 and an I128, all we need to do is implement the, let's say U128. I just need to implement the vector for it, the abs diff for it, right? It's going to say it's not implemented. So we should be able to do that. I32, I64, and U128. Yeah, and then it just works. That's pretty nice. I like that. This is a little above and beyond what's actually necessary to solve this problem, but we now have a generic way of making a diff sum for any type, as long as you implement it for the type. Obviously, you'd want to implement it for all the types, right? So we can actually do that. How many are there? There's a whole bunch. There's oops, come on. I8, U8, I16, U16, I32, U32, I64, U64, I128, U128, I size and U size. Actually, it should work for the floats as well, right? F32 and F64. There's no reason it shouldn't work. It's just subtraction. Look at that. But you can see why you would want to make a macro to do this. And then you could just list all the types and the macro would make all this. I wonder, can you do this? F64? Oh, you can't do min. There is no ord on F64. So that's the difference there. You can do the abs diff trait, but you can't do the min diff. So your diff sum works, right? Because abs diff is implementable, but you can't min on, for whatever reason. You're not allowed to ord on floats. You should be able to partial ord on floats, right? But I guess min needs ord. Oh, can I get away with that? Can I partial ord here? No, it has to be ord. It has to be ord for min. Okay. We learn things. We learn things. This is going to be my final solution because I like it. Git commit -am changed everything to use generic traits. Git push. That was fun. I like doing things like that because it helps me extend my knowledge of Rust.